Hi, welcome to part 3 or 4 of my series on parametric differentiation. So you have got the following parametric equations of a curve. They are x is equal to the natural log of t plus 1 and y is equal to e raised to the 2t plus 2t. You're supposed to find an expression from dy dx in terms of t. Right, so let's go directly into it. So you have got x is equal to the natural log of t plus 1. Now I still hope you remember how to find the derivative of the natural log. So if you have the d by dx of the ln of, let's say, f of x, okay, then it's going to be 1 all over that function, then on top times the derivative of that function. Hope you remember the general form, because I'm going to use that general form over here when I find the derivative of that. So this is dx dt is going to be 1 over t plus 1. Then you multiply that by the derivative of the inside, which is 1. Okay, so this actually will clean up nicely. It will clean up nicely to 1 over t plus 1. This is dx dt, but we are looking for dt dx. Now it's very important you do understand what I mean by that. Okay, dt dx, which will be t plus 1. Because from the chain rule, our application is dy dx is equal to dy dt, which is that I must calculate over dt dx. So this over here represents just that. So this dt dx is this one over here. So I need to find dy dt. Okay, and I can find dy dt. Let me just write down what my y is. Okay, y is nothing but let's just grab it. So y is this one over here. Just hope I grabbed it correctly, nicely. So let's just have it. Okay, so if this is y, okay, just sort of cordon that off. So if this is y, then from here dy dt is going to be, well, the derivative of that is going to be 2e to the 2t plus the derivative of 2t will just be 2. Okay, so this is dy dt, the one over here. Okay, so we're going to multiply them together to find dy dx. Okay, so therefore dy dx and dy dx is nothing but this. Maybe I'll write this one first, t plus, let's write dy dt first. So it's 2e to the 2e plus 2 times t plus 1. Okay, we're good. That is dy dx. Right, what does the question actually want us to do? Let's just quickly go back. It says find an expression. Okay, we did that, so that's part A. So we need to do part B. Right, so we got the expression for dy dx. So part B, they say find an equation of the normal to the curve at the point for t is equal to 0. Okay, so we need those points as well. Okay, so let's just have that over here. So what is it that we know? We know for a fact that x is equal to what is the natural log of t plus 1. We also know that y is equal to e to the 2t plus 2, and just make sure 2t. Okay, so when t is equal to 0, what is going to be the value of x? So that's just going to be the natural log of 1. I'm just going to leave it like that. So x is just going to be the natural log of 1. In fact, if you look at the natural log of 1, the natural log of 1 is nothing but 0. So x is equal to 0. Here, y will be e raised to the 2 times 0 plus 2 raised to the 0. So of course, when they every time when they give you these particular values for the exponential functions, they like to make that t is equal to 0. Okay, so that your business can actually, simplify. So this is going to be 1 plus 0. Then y is equal to 1. Okay, right. So I have got my my point. Okay, so my point that I have, the point is x is 0, y is 1. So we need, you'll see a sequence towards these things as x sub 1, y sub 1. So we need the gradient. But the question is asking for the gradient of, we are supposed to find the equation of the normal. So we first find the equation. We first find the normal gradient that to use the word normal, we're going to find the, it says find the equation of the normal. So we're going to find the gradient value, right, when t is equal to 0. So remembering what our gradient was, let's just go and take a snapshot of it and bring it down. So this was our dy dx. This is our whole gradient. So bring that down. Okay, so that is our gradient. So now we have our point. So we're going to find our gradient when t is equal to 0. When t is equal to 0, what is the gradient here? T is equal to 0. We have got 2 e raised to the 2 times 0. Then that should multiply by 0 plus 1, of course. This is going to be nothing but 2 times 1. So the answer is equal to 2, I believe, is equal to 4. Just make sure that I have that. So it is, I left out something here. Just do my correct substitution. It's going to be that plus 2. Okay, that's what that was. And then you have got 0 plus 1. Of course, this is going to be 2 times 1, which is 2. 2 plus 2 is 4. And 4 times 1 is 4. So the gradient, the equation, the gradient of the normal will be the reciprocal inverse of this, which is going to be 1 over 4 with a negative. So if we have our equation, then we know that the equation should be y equals to, or they have been specific, but let's just write down what it's going to be. So it's our normal that I've already calculated. So it's going to be that gradient, negative 1 over 4. And then you have x minus our x value. So remember our point for x and for y, we already calculated, so to speak. We said if x is equal to 0, y is equal to 1. So x is equal to 0, y is equal to 1. So 1 over here, 0 over there. Okay. And what else do they say? Of course, they probably want the equation in a certain form. And let us just go and grab that. Very important that you always refer back to the question so you don't end up making mistakes. So they say they want the equation in the form ax plus by plus c form. So we are going to say, okay, wait a minute, if that is the case, I have got y minus 1, I'm going to put that in bracket, is equal to negative 1 over 4 And that's obviously just x. Right, so you're going to multiply throughout by negative, and that's going to leave my 4 to be, my x to be alone over there. Okay, remember you have negative, the reciprocal of that is negative 4. And then obviously I'm going to multiply out by distributing this here. So I'm going to get negative 4y, and here you must be careful, that's positive 4 is equal to x. So I want it in this form. So to do that, I'll move everything to the right hand side, and I'm going to say, okay, let x equals to, or let this stuff on this side equals to naught. Then I have got x plus 4y minus 4 if you bring that over. Okay, and this is ultimately, you can rewrite it now. You can say, wait a minute, therefore x plus 4y minus 4 is equal to 0. That is what they were looking for, and that is our final answer. Always read so you can know exactly what is it that you need to do, so you don't jump, and then get wrong answers. That was part 3 of my series on parametric differentiation.